So we're going to bring Kevin up front, and we have time for some questions for Kevin and Robin.
All right, Robin, you got to help me out.
Yeah, Kevin.
I'm here.
Robin, yeah, it's very nice talk. So my question is that you say, I saw you have the goal for net zero energy, net zero water, net zero waste. So if you meet all the goals, so the structure will be quite different. So I guess the microbiome could be quite different from what traditional builds, how the building will build. Do you have any idea how can you achieve this, all the net zero energy, net zero water, net zero waste? How can you achieve this?
Well, I agree that they're likely to be different, especially given, I'll just talk about the Bullitt Center, which has done all of those things. It uses less energy on an annual basis that it collects in its rooftop photovoltaic array. It collects all rainwater and treats it on site through various systems, including many that look a lot like traditional sanitation processes, but just at a micro scale at the building. And it takes all waste and treats it in composting toilets, 6 large bins in the basement. And the question is, does that building's microbiome look different than another's? And I would say probably, but we don't know. And I think it'd be a great thing to study. This is the future of architecture in many ways. Whether or not these things are going to happen at an isolated individual building level is still, I think, a big question. But the notion of kind of closed loop systems and trying to find the right scale, is the right scale for water sanitation at the whole city level, or would it be better done, more effectively done at a district or a several block radius level? Is photovoltaics on the top of every building logical, or would it make more sense to have distributed smaller arrays, those kind of things? But I think it's part of our built environment future.
So, Robin, I wanted to thank you so much for your very helpful talk, and wanted to reinforce your concern about proprietary antimicrobial building materials by sharing with people who may not know that the FDA just in the past month banned triclosan from and some other chemicals from soaps that are antimicrobial, because triclosan has hormonal activities, and there was some concern and no evidence that it's helpful. We don't know, I think you're telling us what is in the building materials that and the paints that are antimicrobial. And I do agree it's important to understand that.
Thanks. It is the biggest quest these days.
A comment that, so both of you, I'm very happy, his first talk bringing up the aesthetic part, because when we talk about human health and well-being, I don't think it's all cost-benefit analysis about how much it costs to heat our homes. But the notion that has been underlying many of our talks, and I appreciate you just, holding forth on it, is this fact that so many people are afraid of microbes. We've been trying to figure out what it is they do well, but if we have a culture that is microphobic and that it sells products, and that we have hospitals that are totally microphobic because they work on a few, we have a social problem that I think this study group has been ignoring, and I'd appreciate one of you commenting.
I'll jump in first. I think you're absolutely right. It's really important that social understanding of the research that we're doing and its interpretation immediately conjures a crinkly nose and an ugly-looking face. And so we have some work to do. But again, I would say just one point of reference for architects is we are good at helping to revision or reimagine information. And I don't think it's just spin. I think we can aesthetically, through inspiration, change collective conscious about what it means to, to understand that we live in communities, in microbial communities.
And I'll just add that I think that architecture follows food, and building products follow the food industry, and by that I mean that this quest for labeling, you might say it's the next big industry after food to really look for ingredient labeling. And I think it is the next big industry. Food has sort of begun to promote probiotic attributes of food products, recognizing that the human gut's microbiome is in fact important, and a healthy microbiome is important to human health. And consequently, I think that if we apply that to architecture, I believe that already architects and people around buildings are actually lifting up their heads and saying, there is a functional microbiome in our buildings, and disturbing that microbiome, we need more understanding before we just play games with it, particularly since we understand that resistant microbes are presenting more and more difficulty in human health. And so I think it's a good moment to embrace the idea of building microbiomes. As Kevin said, I think it's the right time to bring that up.
I wanted to jump in on one more small point, just kind of a practical dose, maybe. We're trying to talk about this research with real architects on projects. The one I showed, the lobby airflow study, was one example. And the mechanical engineer piped up and said, well, hold on a second. We want 3 times, 4 times, 10 times the amount of fresh air, maybe, designed into our infrastructure, the potential ability to deliver 2 times the amount of fresh air. That's a different starting point for HVAC design. Right now, the momentum is low energy driving the agenda, and we're going to radiant heating and cooling systems that have separated the heating and cooling component of our needs from the ventilation component. When we were delivering heating and cooling through ductwork in the ceiling, it was the size of the ductwork was determined by the heating and cooling loads, not the ventilation loads. Now, with heating and cooling being delivered through radiant water-based or glycol-based systems, we can resize those ducts, in many cases eliminate them. And if we learn fundamentally that we want 2 times or 4 times the amount of fresh air, the most energy efficient buildings in the world right now, they have two types. It's the hermetically sealed thermos bottle with very careful amount, this is passive house, that's the buzzword, with very careful heat recovery ventilation and small amounts of fresh air. Or you've got passive buildings that are designed to open up windows and night flush cool. The passive buildings that open windows and night flush cool, they can deliver 20 times the fresh air required for ventilation, inherently.
So I have a question for both Robin and Kevin. So this is Jessica Green. Robin, your book, Sustainable Healthcare Architecture, was so inspiring to me when I was first launching in this area in 2009. I consumed every word. At that time, my access to practicing architects, was really through Charlie Brown and his work. I'm wondering if both of you have ideas on what is the best way for the research community, so people that are in academia, a lot of people in this room, to be connected to people like you that are out in the field, that are practicing architects, so that we can really close a loop and make sure that we are answering research questions that have real relevance in application for what the makers and the doers are engaged in. So if you could help us think of different models for doing that, how can we operationalize involving practicing architects in the research as we're formulating the research questions and conducting the research?
So I'll start, and then Kevin, if you will add on. I do think more and more firms, particularly larger firms like Perkins+Will or AECOM, or you name them, in the U.S., are actually interested in participating and being part of research studies, and and sometimes helping to fund research studies, because we see these questions as so fundamental to the future of practice. And pairing, actually doing collaborative research with academia, with medicine, etc., is what more of us are willing to embark on. And so I would just encourage you, I think I saw you at the AIA convention last year, right? Encourage you to continue to network in those networks, continue to look for opportunities and have dialogue with architects, constructors, and large portfolio building owners who also have a vested interest in making the right decisions in the design of buildings that they're going to own and sometimes occupy for a number of years. So that's one thing I would say.
I think that's
Kevin?
great, Robin. I have two-part answer. The first part is this is exactly the reason why we think it's important to work with industry. So architects, engineers, building product manufacturers like Johnson Control, Siemens, and I think getting those folks around the table and getting them clamoring for federal support is probably the most important agenda that we need to push, because I ended on the slides that show the microbiome of the built environment is seeing 1% or maybe 0.1% of the funding that energy efficiency has seen, and I've been dismally unimpressed with our progress and the slow progress that we've made on energy. Now I'd say I want every building to be net zero. We have one, we have 10, but we don't have, this is a 1/100th of 1% of our new construction stock. So it needs to scale up, and that needs funding. I think the industry consortium idea that we're talking about at University of Oregon is part of it. But the other one that I think is more practical to every single person who's sitting in this room that lives in an academic institution is your institution owns a lot of buildings. You need to find a way to get at the seat at the table when those new construction projects come online, and make sure that they're at least aware of this research field. So that's making friends with your facility operator at the top level. That may be director of campus operations or director of campus facilities. And then hopefully working with them to do some on-campus university-based research and make them a part of that process.
So, over here. So I've been sort of following the sort of Starchitect designs for some time, looking at how these sort of things are conceptually put together. And one of the things that I notice about these designs is a lot of the buildings are, say, to me, when I look at them, don't come in here. They're not built, they're built to impress. They're not built at a human scale, and there's nobody standing around them. So when you look at the bottom floor where there's people, if we want to get people fresh air, one best way to do it is actually have them be outside. Yeah. Right? And so when I look at our architecture, at our mission style architecture at San Diego State, which is built in the 19th century, and not only is it incredibly solid, but it's full of breezeways. You always want to be outside. The doors are open. You've got this cooling mechanism that go back hundreds of years, where you have towers that cool the buildings. I mean, it's all just really easy and pretty, and you just want to go outside. When I look at a lot of stuff I see built over at the other place, it's just these giant monstrosities that are just, there's nobody there.
Yeah.
So what do you think about incorporating the human element into this?
Well, I think it's a good question, and the reason, the brand or the notion of Starchitect, I mean, Rem Koolhaas is a good example. I'm not sure, I don't know Alejandro personally, but I think his brand of architecture is a little different, a little more, or a lot more human. And for what it's worth, he's today's Starchitect, right? Many of Koolhaas's buildings, or a lot of high-profile, high-style architecture, it's in that 0.1% category as well. What I find inspiring about Alejandro's work is it looks every day, it looks usable. I don't know if it performs, but I think what's important is to kind of capture to ride the wave that these buildings, like the Bullitt Center and like the project we're trying to design, right, the healthiest building in the world, the market transformation component of that is it gets a lot of press, it gets a lot of attention, and therefore people look at it and try to follow suit. Architects are great at ripping off good ideas from other architects, and I think we just need to put these good ideas out in a way that's aesthetically pleasing and inspiring, and that you can use that to our advantage. But to your point about human scale, I'm definitely with you.
And and I'll just add that I think in the realm of those two directions in buildings, the direction of tightening down the passive house way and the direction of just passive design, which opens up, I think you're seeing both of those progressing. I certainly think that wellness and the idea of the therapeutic value of being outdoors and the health value of being outdoors for all of us who spend so much time indoors is beginning to really penetrate lots of sectors of the architecture marketplace, whether it's higher education buildings, science buildings. You're even seeing it happen in healthcare, where there are experiments being done with natural ventilation in parts of hospital buildings, and sort of doing it as much about resilience and passive survivability, and certainly much more interest in finding ways to allow staff to get outside during the workday in healthcare. Huge kind of groundswell of that. And I think the buildings are getting actually much more pleasant as a result. More daylight, to Kevin's point.
I like the notion of stopping on the note of more daylight. Thank you to both Robin and Kevin. Thanks to Jordan for organizing a terrific session on which to end our formal presentations. Just to reiterate what I said at the beginning, the formal part of our public meeting ends now, but please stay for lunch. And then the members of the committee will reconvene this afternoon to roll up our sleeves and start writing. Thank you all for your questions, your participation, your interest, and let's go and see if we can do more good science. Thank you.